Good morning, good afternoon, and good evening. And thank you for joining today's Wednesday webinar on Agentic Document Extraction. We have my favorite host, Andrea Kropp, who is our senior machine learning engineer, and she works very closely with our customers and the user base on ADE. Wealth of knowledge. She is your expert here. With that, my favorite person, take it away.
Oh, Adrian, you're my favorite MC host for sure. Okay, so let's get into it. And yeah, thank you for submitting those questions in advance. I'm going to make today's session a little bit more at the intermediate level. So I'm going to cover some of the beginner topics, but based on the questions that were submitted, want to get into some code-based examples, want to get into some like RAG specifics. So I'm going to go lickety-split through some of these initial slides. So agenda for today, we're going to do some work in the visual playground, look at some tables, handwritten documents, lots of languages. I do want to do some code-based examples, and I will touch on things like pricing and hosting options and security, mostly just showing you which public pages you can get more of that detail for yourself. So I'm Andrea. I've worn a lot of different hats in my career. I'm currently embedded with our go-to-market sales team, mostly supporting the west of the United States. So if you're in that enterprise segment, you'll probably meet me over there. I live in Washington State. If you're ever in the area, my hobbies are tennis and board games, and happy to connect with you. So, if you are new to LandingAI, think of us as a vision first company. So, we come from the computer vision space. We're treating documents as visual entities first, rather than treating them as, I guess, words first. And this has really allowed us to achieve kind of breakthrough results in this document processing space. We've been around for about 7 to 8 years. We do have another product in the computer vision space, but today we're going to be talking about agentic document extraction. We are founded by the amazing Dr. Andrew Ng, who still serves as our executive chairman. He is very much a respected thought leader in the space, and kind of under his leadership have developed some of these foundational models, and have processed over 1 billion images and documents so far. So, in this great Forbes article from the end of last year, Dr. Ng talks about the fact that we're kind of past the era of one size fits all kind of large language models. And his prediction for the future is that we're going to start to see more kind of niche models that are good at particular AI workloads. So that's really what we're talking about today. We're going to be sharing our document pre-trained transformer, DPT. And this is a model that is specific to work on documents, not a one-size-fits-all kind of vision language model. So that is our ADE. Basically, we think of this as a document intelligence engine. It is zero shot, so you're going to just drop your document in, allow the DPT model to apply kind of an agentic framework to analyze and understand that document and return back to you JSON, which is ready for production pipelines, and has visual grounding and verified outputs associated with it. Um, we're going to do a lot of visual work today, but it's important to remember that ADE is accessed as an API. There's a REST API, Python library, TypeScript library. If you're working in Snowflake, there's some stored procedures there. So the intent is to explore the product visually and then work with it programmatically. And there are three separate APIs that are typically used in this order. So first, parsing the document, which is going to basically create a representation of everything that exists in the original. The split API, in case you have a bundled document that you actually need to like disentangle and separate into different pieces. And then the extract API for pulling out key value pairs. Definitely encourage you to check out some of our benchmarks. We are kind of at the top of the leaderboard for the Doc VQA benchmark. VQA here is visual question and answering. So these are documents paired with a question that might be, what is the total on this receipt? And so you need to be able to understand the original and then answer the question. So we are currently sitting actually above human performance on that. And what I really like about this benchmark and kind of how we've displayed it on our website is you can see all like 5,000 documents that are in the test set. And so you can actually see the performance on those. So rather than, spending your own time running 5,000 sample documents, definitely take a look at the variety that's in the benchmark. There's lots of faxes and scans and handwriting and checkboxes and other languages. So there's really quite a variety in there. Not going to spend too much time here, as Adrian mentioned. If you are kind of looking to kind of go the next level and kind of really get your security questions answered, think about, could we make this HIPAA compliant? How do we isolate our data from other users? These are the types of conversations that we have in the enterprise segment. Just know that everything on this slide does apply to our multi-tenant SaaS. So although we do have other deployment options, we definitely want you to first exclude the fact that maybe I can't operate in multi-tenant SaaS before you pursue one of these other more complex deployment options. These then are the deployment options, right? So over here on the left-hand side, we've got multi-tenant SaaS. You can spin up an account instantly and start testing your documents, and you'll see me testing in our multi-tenant SaaS today. We can also set you up with single-tenant SaaS. We can deploy our solution in a container in your VPC, so AWS, Azure, or GCP. And we do have a version inside the Snowflake marketplace that integrates really nicely with Snowflake's Cortex services. Last couple slides, and my goal for today was to get into the demo much faster. So we see quite a myriad of use cases, but typically they fall into two categories. So the first category is field extraction. So starting with documents such as the five you see on screen here, typically the goal is to find a particular value on this page. So it might be pulling out the box one wages, or pulling out the passport number, or pulling out like the total earnings for the year. So field extraction is very common, starting both with scanned documents, digital native documents, photographs of documents. I neglected to include a handwritten one here, but like in the applications for insurance and things like that, you get lots of handwritten. So lots of field extraction use cases. And then typically, the goal with field extraction is you've got a variety of originals and you're trying to create some sort of structured output, typically save that in some sort of a database. Second really common use case is preparing documents for RAG. If your documents are almost entirely text, you have a lot of different options for how to chunk that text. But once you get into documents that have kind of complex tables, have figures, infographics, line charts, scatter plots, those are often ignored by a lot of chunking approaches, and you lose a lot of the rich detail that actually exists in those charts and figures. So with our agentic document extraction, you get a true representation of the table, you get a narrative output of what's in the flow chart, you get a description of the axes and a reproduction of the data points where possible for any sorts of charts. And so when you use that as your chunking strategy, you have a much richer RAG solution. So in this example, here are the original starting documents. You would run them through our parse API, save those chunks into a vector database after applying an embedding model. And then we don't really get involved in creating the user interface that's going to interact with that vector database. So this is really up to you. But I am going to show one today in Snowflake. Like I said, very easy to integrate with Snowflake Cortex services. So you'll see that ADE has prepared the chunks, and then Snowflake provides the user interface to actually interrogate those chunks. So we do work very well on lots of different types of documents. I like to call this, designed for real world messiness. So I try to include as many messy documents in my demos rather than lots of just pristine examples. But do know that, cell phone photos are fine, scanned and faxed pages are fine, handwritten. We really make it very easy to try. So if you have like layers of complications in your documents, you can just try those for yourself. I think I succeeded in 10 minutes on the slides. So let's go do some things live. So I'm on the LandingAI homepage here. I just want to note that this blue Start for Free button will allow you to create an account in the US or the EU region. It'll come with 1,000 credits, which is typically enough to do like 200 to 300 documents. So, or 200 to 300 pages, I should say. So plenty of credits to kind of get started. So once you do that, you will be on a page that looks something like this. So as I previewed in the slides, there's a parse, split, and an extract API. But everything really starts with parse. So even though you can upload a file to use these two services, it's actually going to call parse first. So let's go ahead and just start with parsing. And the demonstration we're going to do today, we're going to use some utility bills. So these are typically pretty easy for people to understand as a demonstration. And all I've done right now is just kind of drag and dropped this kind of 3-page bill from Duke Energy here into the visual playground. So what's happening right now is this is calling our DPT-2 model. There are different models available, which you can access from this drop-down menu. But currently DPT-2 is our latest model. There's also a mini version of that model. So what we've gotten back now, it took about 5 to 10 seconds, is a Markdown and a JSON representation of the original. So first thing you'll notice is the highlighting of the different chunks. So here we have a logo chunk, which is so I guess number one is your energy bill is this text chunk. Number two is this margin chunk. Number three is this logo chunk. Then we get into another text chunk. So we're both identifying the chunk type and we're trying to maintain the human reading order of this as much as possible. So chunk 10, 11, 12, 13. So this is particularly helpful when you have multi-column layouts in your document to actually maintain that human reading order. So we can kind of tab through this document. In the visual playground, there is a limit of 100 pages. So typically, within your 100-page document, there's like 4 or 5 pages that are difficult that you're actually interested in. So I would encourage you actually just to, if you open it up in Chrome and use like save, you can save just like the 5 or 6 pages that you're really interested in testing and then drop it in here so you don't have to do the whole 100 pages. Okay, let's take a look at something like a table output. So you'll notice that the visual playground here is interactive. I can click on items on the left-hand side and actually see that representation on the right-hand side. And this is usually where people are kind of, zooming in and kind of like checking the values, going back and forth to see if everything has been recognized correctly. So definitely encourage you to do that. Okay, let's explore the JSON response just a bit here. So here we have the same chunks presented. Here's a text chunk, margin chunk, logo chunk. This again was the top of page one. In Python language, of course, these are all page zero. And then we have the actual relative coordinates for where on the page that is found. And so this is going to allow you to do visual grounding. Whether you're doing field extraction or RAG, you can always refer back to where a particular value was found. Everything will have a unique chunk ID, and that chunk ID will have a specific page location that you can reference. So let's go ahead and preview some extraction on this because it'll help explain kind of how the JSON works. So within extract, um, say that I'm looking for just the like total amount of energy used. And is this a electric and gas or just an electric? Looks like just electric. Okay. So I can basically start from scratch and I can say something like, you know, kilowatt hours used. And I'll make that a number and I'll go ahead and run that schema. So, very quick and dirty, kind of in the visual playground, you can gradually build up your own schema. When you run it, you're going to get back the response, so 1059 kilowatt hours, and you're going to get back the reference for where that was found. And in this case, it was found inside a table. So I'm not getting back the reference to the entire table. I'm actually getting back the reference to the particular cell where that was found. Now, this is not a particularly complex table, right? It's maybe like 2 columns by 5 rows. But as you get into massive tables of, 30 columns by like, 20 rows, it's very helpful to say this value was found in this cell, not like just this value was found in this table. So you can absolutely build up the schema kind of piece by piece in the visual playground. Definitely encourage you to fill in the description. The description is actually where the magic happens with the extractions. Think about it almost like prompt engineering, that the more richness you put into the description, the more the model is going to understand what you're trying to get back. So just for demonstration purposes, let me like upload a utility schema. So this was prepared in advance just to kind of show what's possible. And here you see that we actually have filled in much more of the detail. So we've included information about how we want things formatted. So a date, we want it formatted in a particular way. So the magic here is definitely in the description. So take the time to fill that in if you're not getting exactly what you want. This schema supports 5 levels of nesting. So what you're seeing here is 2 nested levels. And I did prepare this in advance in JSON. We can also support Pydantic schemas with the API, but for the visual playground, you'll need to upload it as JSON. So here we have, a much more robust output. We've got the same kind of demo that I had asked for here was under electric charges, the usage in kilowatt hours. So we've got that same 1059. We could have asked for the numbers to not have commas in them, right? That's part of what you're going to pass as part of your schema. But now I've got this nice kind of extraction from that original bill, as well as all of the visual references. Okay, let me pause there. I'm going to take a sip of coffee, see if we have any initial questions, and then we're going to start to do some more robust examples.
We did get a great question. Can you parse and extract a document into a custom JSON that you give?
Ah, so not on the parsing step. The parse step is just going to give you back a JSON that represents the entire document. So if you don't need the entire document, well, you're going to get the entire document back anyway in the JSON. The extract, you just saw me upload a JSON schema, so maybe that question was written before I actually did it. But that's exactly what you're supposed to do with extract. You're supposed to supply the schema in JSON, and you can get back exactly what you want.
Excellent. If you want to go ahead and continue.
So I have a couple other tabs here open. These are just other example documents that I had pulled out in advance for parse, and then we'll look at a couple extract. So here's a 10Q document. First couple examples here are a little bit more like finance and financial services. So this is a 10Q from NVIDIA. Right, so this is the type of document that is going to have a lot of tables. So just showing table support and, including things like, negative values in parentheses, important to get correct when you're dealing with financial extractions. So just an example of like a longer financial document. So we see a lot of people who are doing investment research and advice or securities research, kind of parsing these types of documents. Um, Also in the finance space, here's an example of one of those long tables, right, where it actually matters to get like the particular table cell reference. This one looks like it's still highlighted from a question that I had asked before. But we provide this chat experience just for convenience. We do not have a chat API, but in the visual playground, we have this chat experience so that you can kind of anticipate how this might work. So I can ask a question like annual premium for, we'll change this for policy 3 in year 16, and we'll go ahead and ask that question. Okay, so I'm getting back the response, right? And here it's telling me, okay, policy 3, year 16, and the premium for that is $12,000. So this is a nice example of having parsed this entire kind of more detailed table and then being able to ask questions of that table and get back those particular cell references. So nice example from kind of a longer, this would be at the end of a life insurance policy to show the premiums per year or show the comparison across three policy options. Another example from finance, we see a lot of handwritten documents in the finance space. So there can be applications for credits, there can be like disputes of charges, there can be, um, you know, um, like if you have to file a claim, like a homeowner's claim or an auto insurance claim, right? There's a lot of handwritten documents. So here you can see like how we deal with checkboxes, right? So this is an application for the Visa Platinum card. This person has marked the low rate option. The text is extracted where it's legible. This sample is actually my handwriting, and this one is my husband's handwriting. So kind of funny that his initials are illegible, but mine were okay. Um, this is all fake data, right? But it does show that the handwriting is extracted correctly and also show our attestation type, which will specifically detect signatures and will try to also read the signature if it's legible. Also in the finance space, we see a lot of analysis of kind of PDFs or like PowerPoint presentations. So I'll just kind of tab through this one. So this is a typical kind of investor presentation. And here we start to get into a lot of different charts, right? Because a lot of the information is conveyed kind of over time or relative to other geographies. So you are going to get back an extraction for each particular, I'm trying to click on this to actually update it. There we go. So here, figure 67, I just kind of clicked on this one at random. But it's telling me this is a stacked bar chart showing mixed revenue by product for different periods. It's able to extract the legend, and then it's doing its best to actually reconstruct the values you would need to reproduce this chart. So again, from a RAG perspective, we're able to incorporate a lot of the rich details that are in the figures. And so if downstream you want to be able to chat with this document, you're going to be able to chat with the figures in the same way that you can chat with the text itself. So we see a lot of these types of documents that have kind of unique infographics, kind of non-standard chart types. that are really quite nicely understood in the figures. Okay, got a couple healthcare examples. So, so this is a research article about the common cold. We're definitely seeing a lot of interest from researchers being able to build RAG solutions on top of a set of research documents. Again, here's a nice demonstration of keeping that human reading order. So block 24, 25, then up here for 26. Nice illustration of interpreting scientific charts. So, we're getting getting a lot of details here, like 5 pascals per cubic centimeter per second at time zero, right? So we're getting more than just the caption for the figure. We're actually getting an understanding of what's happening. For a simpler line chart like this one, you will also get the values are extracted quite accurately. And again, this is all done out of the box, zero shot, so you don't need to specifically request this. Here's another example from healthcare. I like this table just because this final column has things like empty circle, empty circle, 3 filled circles. So I just find this an amusing example. Again, it's that combination of like infographic with charts that kind of often gets lost in translation. Here's an example with checkboxes. So kind of going back to like in the healthcare space, there's also lots of checkboxes, a lot of patient intake forms. So, here's an example, how did you hear about us? And just being able to record those types of options. And then I've got a couple kind of random examples at the back here. So, can we handle bad scans? Yes. It's always a matter of how bad is bad, but this was one of the pretty bad ones that I've pulled out. So you can zoom in on a number like this reference number. You can check over here if it's extracted correctly. Let's see what chunk it's in. We're not going to do that together, but I have actually checked this in advance. Otherwise, I wouldn't use it as a demo. So this kind of reference number, order number, this is a pretty badly degraded original, but we're doing a pretty good job on these. And you'll see this in the Doc VQA benchmark as well, that there's some pretty badly degraded originals. Want to draw attention to the fact that we do kind of identity documents. This is actually its own type. This is identified as a card type. And so it's actually identifying the entire entity as being a card, right? So it's its own type. Here we're also starting to get into some language support, right? This one is in Spanish, but it's all kind of digital native. And then the last example here is this is just a nice way to show multiple languages. So a lot of documents end with this kind of notice of availability in other languages. So it's a great way to just put several languages on screen and have the parse results over here side by side. So if you speak or read any of these languages, I'll leave it to you to do the on-screen verification. And let me pause there and see if there's any questions.
We have a great question. What does it do with, or how does it handle PT or PCI data in the document?
Anything that is legible in the document will be part of the response. So if you are trying to redact information, you would need to do that and nicely black it out before you send it to our parse. As I mentioned before, and we can kind of preview some of the security here, our solution is SOC 2 Type 2 and HIPAA compliant. So it's okay to send PII and PHI as long as you've set your account up the right way. But if you don't want to send it, you would have to redact it from the document before you send it. Anything else, Adrian?
You're good if you want to continue.
Okay. So we're going to do a couple extract examples, and then we'll get into some sample projects. Here's the Duke Energy bill we did at the beginning. I just wanted to make sure that we covered this one for extraction. So we did this one already, so we're going to skip this one right now. Um, let's take a look at this document. So, oh, and here's an example of the redaction, right? So, like, if you don't want the patient name or date of birth, like, you will have to actually block it out. Otherwise, it would be there. And you will see actually in the response here, in this case, yeah, patient name is blank and date of birth is blank. So this is a two-page fax, very common in the medical space. Oh my gosh, so many faxes still in medicine. But initially, when you look at it, it doesn't look like a document that has a lot of key value pairs or a lot of structured information that you can pull out of it. But you can do something like this, right? You can pull out, information about when the fax was received, who sent the fax, what patient is this fax about, what sort of study was done. In this case, it was an MRI, and then what's the report of findings. So you can take something that actually looks pretty simple and unstructured in a lot of ways, right? This is just kind of like a dictated note from a physician, and you can actually convert that into highly structured information, including kind of who dictated the note, what the final finding was, who sent the fax, and so on and so forth. So I like this example because it seems highly unstructured and then converting it into something quite structured. Um, this one, by contrast, actually seems more structured from the get-go, right? Because these are key value pairs as you're filling in forms. Here in the parsing result, it's another example of like how do we deal with things like circled responses. So here, the person has circled no in all cases, but we've just marked that as option no. And then same with circle all that apply. We've got all of the options listed as well as the ones that were marked. So when you turn this into an extraction schema, oh man, okay, now I have to re-upload it. Let me see if I physical therapy schema. I think this is the right one. Okay. So I wanted to draw your attention to this middle section, right? So this is the Physical Activity Readiness Questionnaire, or PAR-Q, right? And there are 7 questions. So you can convert that into like a nice structured output like here. So responses to the PAR-Q screening questions. I've set these all up as Booleans, and so I can just get back a nice structured response, like the person has marked false or no for all of those. Similarly here for kind of pre-existing conditions, I've defined this as, list of conditions that are circled. And so it is this response here where I'm now getting, rather than getting back all of the responses, I'm just getting back the 4 that are circled. So it's a nice example of kind of how to use parse and extract to get the final structure that you actually want. I could have gotten each one of these pre-existing conditions as a Boolean, or I could have gotten the PAR-Qs as a list for any that were true. So it really depends on how you define your schema, what you get back. And I forgot what I picked as my last example here. Oh yeah, okay. So this one is a lab report. It's showing another type that we haven't seen yet, which is this scan code type. So anytime there's a barcode or a QR code, that's going to be detected as a scan code. You're also seeing 2 attestation types down here at the bottom, but really wanted to focus on this table in the center. So when you're getting back a blood test report like this, you may not actually know all of the fields that are going to be in the rows, right? So in the previous example with that PAR-Q questionnaire, I actually listed out all 7 questions because it's a standard questionnaire. But here, what I want to do is just create an array of all of the lab test results. So I don't know in advance what's going to be in the report. I just want an array of all the results. So I've got the name of the test, the unit of measurement, the test value as a number, and then here the reference values. Oops. I don't even know what I just clicked on my keyboard. That might, oh, that might be helpful to know how to do on purpose, but I did not do that on purpose. Um, and then you can see the reference values. You could extract these as a string, but I really want them as numbers. And so I've defined reference value low and reference value high. So now I'm getting this kind of structured result back without having to define, I want the hemoglobin, I want the leukocyte count. So again, without knowing what the rows in the table are going to be, you can get back an array of all of the results, as well as the converting these reference values from string into numeric. So hopefully that gives you some ideas for how to use extraction. The accuracy of the extraction has everything to do with the accuracy of the initial parsing, because when you call the extract API, it's actually interacting with the output from parse. So extract is not going back to the original document to look for the answer. Extract is looking at this markdown output. So the extract accuracy has everything to do with how well you define your schema and how well the document was parsed in the first place. Let's do a couple other things in the visual playground, and then we're going to look at some sample projects. So I've had this left panel collapsed most of the time, but there's some important information here. So one, you can go back and examine previous documents again. So I can go back to this electric bill. I can also share this with other people. So if you hit the share, you can make this document public, and now you can send this link to other people and they can take a look at it. So if you're working in a distributed team, you don't need everybody to parse the same document. Just do it once and share it. Now, this file history is only available for accounts that do not have the zero data retention turned on, right? So if you, skipping back to security here for a moment, if you do have an account with zero data retention, you will not have a file history. You will go there and there will be nothing. And that's because in that case, the data is processed in memory and is not stored by us. And so it's important that you actually save what you're doing, because if you close the browser and come back, it will just be gone. I guess we were working here, yes. So if you have zero data retention, which is required for HIPAA and processing other sensitive documents, you will not have this file history. And so if you navigate away from this page, your results will be gone. You do need to save the work that you're doing. Other important things here are the link to the documentation, which we're going to look at next. And if you click on API key, this is a place where you can create your key. You can have multiple keys so you can track usage from different departments or different individuals. You can then see the usage, and I find it more easier to see kind of this daily usage. And you can see whose key is doing that work. So this is distinguished between the playground, and like this is the name of one of my API keys is Kropp GitHub. So in the logs here, you can see the total usage, you can see it by API key, and this is really nice for kind of like chargeback purposes within an organization. So I am working inside an organizational account. When you first create your personal account, you're not going to see some of these things. Whoa, oh my gosh, all my dials are spinning. So I think I just got logged out somehow. See, it's a real live webinar. Okay, I was going to talk about documentation next anyway, so let's do that. So all of the documentation is public. So we're at docs.landing.ai. You can access that from the link in the playground, or you can just type this directly into your browser. From here, you basically have documentation for four different ways to interact with our service. So there's the playground documentation, there's the API documentation, there's the Python library. Oh, that opened in the same window. That's okay. And then the TypeScript library. So think of this actually as like four sets of documents in one. So most of learning how to work with the playground is going to be here. You saw this API reference open up. So this is the documentation for the REST API. There's going to be sample code here in a couple different languages. If you're calling the EU endpoint, it'll be slightly different, right? So here's the URL for the US-based endpoint. If you've created an account in the EU region, then you'd replace this every place it shows a URL. This is also an opportunity to introduce parse jobs. So we've talked about parse, split, and extract. What is parse jobs? Parse jobs is intended either for very large files or very large batches of smaller files. So the parse API, we would call the synchronous API, it can handle up to 100 pages. And we intentionally set that limit because over 100 pages, we really want you to send it to parse jobs, which can take a document up to 6,000 pages. So in this case, you're going to process it asynchronously, and you will poll to find out when the job is done, and you can retrieve that result. So parse jobs is for async usage or batch usage. Um, and this is going to allow you to send much larger files and also send more files simultaneously. A couple other things worth noting in the documentation. There's a nice quick start here to kind of get started quickly with curl, Python, TypeScript. We've found that we do a lot of these demos in the visual playground, and then people are like kind of stuck in the visual interface and they're not moving over to code. But again, we want you to interact with the system programmatically so that you can actually scale it up. And down here at the bottom, there's more information about security and pricing. A lot of this is the same as what's on the website. So if you come in here to pricing or you scroll down to the footer for security, but there's a little bit more detail in the documentation. So if you're looking for kind of that double click on the pricing and the security, just scroll down here on the left-hand side. Okay. And so how are we doing on questions?
You're actually really good.
Okay. I'm going to take you through a couple sample projects. Let's talk about sample projects. So the utility bill that you saw me do parse and extract for is part of this sample project, which is in use cases and then in utility bills. So here you can find some starter code to apply the same schema to multiple bills. So in this case, there are 9 different utility bills provided in this input folder. So we've provided all of these. We were working with Electric 4 earlier. And this will take you through kind of setting up to use ADE programmatically with the Python library for the first time. So here we're using the Python library. So we're going to process everything that's in this input folder. So that's kind of the structure here. There are 9 items found in the input folder. There's the utility bill schema, which is the same one that I showed on screen, but which you can access here and reuse for yourself. And um, I didn't realize I printed the whole schema. And then it's going to go through just kind of how the process works. So like let's start with processing a single document. So here you see the parse. And then we're just, printing some of those responses. So you can see some of the components of the response. And then we're doing extract. So, and then just printing a few of those items. So these are actually all also saved to this results folder. So you can take a look at, for electric bill number 4, which we did together, you can take a look at the markdown and the parse response and also the extraction response. So this can be a nice way to give demos to others in your organization without you having to actually build this. So you can grab, one of these documents, you can show it to them in the visual playground, and then also be able to show these various outputs. And of course, the goal is going to be to do something kind of structured and summarized. So if you scroll all the way down to the bottom, oh my gosh, didn't need to print all of that output to screen. Ooh, okay. All right. All the way at the bottom. Um, so ultimately, this is usually what people want in the end. So here's electric bill number 4 from Duke Energy that we saw at the beginning. Now we have all of our structured fields extracted, and then we also have the chunk references. So this would be a nice example of kind of how to parse everything in one input folder in some sort of a batch process by sending everything to parse and then to extract. I'm going to highlight one other sample project, which deals with RAG. So this one is also in sample projects. This one's in workflow, and it's the Snowflake intelligence agent. This one, actually, the entire setup is done in this one SQL file. So everything I'm about to show to you was done with this one setup. When you're working inside of Snowflake, you have the option to work with ADE in SQL, which can be a nice benefit. And yes. So the core part here is API parse and then API extract. All of the rest of this SQL file actually then like builds the entire Cortex intelligence agent and the RAG solution. So let me shift over to Snowflake. This may have timed out during the webinar. There's this blog post which kind of goes through this entire structure. So we're going to look at this medical device agent. So I'm here at ai.snowflake.com, and this is kind of the front end experience for making chatbots available to non-technical users where they don't need a Snowflake account, they don't need to go into the back end, they can just go to ai.snowflake.com. And in this demonstration, we're going to ask this question. So what sizes are available for the X-Core pediatric pump? So what you're seeing here is the Snowflake Cortex Intelligence Agent is first going to translate this into a SQL query. It's going to try to understand if in the structured data it can find an answer to this response. And it also has access to all of the chunked information. So I'll have you actually like work with your Snowflake rep to understand more about what's happening at this point. But we'll wait for the response here, and I'll show you kind of how that ties into the chunking that was done on this document. So this is exactly what I was expecting. So there are 6 sizes. It gives me a list of those sizes. And importantly, it's giving me reference information. So if you look carefully at this reference, it kind of starts with the triangular brackets there with actually like a chunk identifier. And then it says, figure 1. So this is actually a chunk that was parsed by ADE, and you kind of recognize like our chunking structure as you look at this. So this is the visual grounding that goes along with this answer. And if we come into the Snowflake backend, yes, okay, this is what I wanted to share. So how was this prepared? Again, this is all done with that one SQL file, which is up on our GitHub. So inside this Snowflake stage, we have 7 documents. So first we want to parse all of those documents, and you saw that in API parse. So if I preview this, I'm expecting 7 rows where each row corresponds to one document. So these are fairly long, 20 to 50 pages. I parsed these about a month ago, and I have the entire markdown response and all of the chunks all saved in this one table. So here I've got 1 row per document. Then, of course, for a 49-page document, there's going to be a lot of different chunks. So here for any one document, I have all of the individual chunks. And you can see the individual chunk IDs and whether they're text, margin, figure, and then the markdown. So that response that we're getting from the Cortex agent is referencing back to one of these chunks. In this particular demo, we also ran some field extraction on those 7 documents. So initially, we just get back 7 rows of some of the structured fields that have been extracted. These happen to be FDA application documents, so things like applicant name, applicant address. And that, of course, can also be parsed into a structured table. So this is very much like the utility example where across the 7 documents, there's an applicant name, there's an address, there's an approval date. Right? So then when going back to the Cortex agent itself, which tab was it in? Over here. So it has access to that structured information and it has access to all of those individual chunks. So I can ask another question, such as this one, return a table listing all the devices in the database, right? This is just a way to show that it's able to execute SQL and also return all of that structured information. So without doing a full kind of Snowflake tutorial here, the structure of this is all described in this blog post. And all of the code that you need to do it is here in this sample project. So if you happen to be a Snowflake user, this is a great way to get up and running with a chatbot very, very quickly with one long SQL script. And I'll highlight this sample project as well. So this one we call parse, classify, extract, visualize. I'm just going to scroll down to the visualize portion because we talked a lot about the visual grounding and the value of knowing that a particular chunk came from a particular location on a particular page. But that becomes much more evident when you kind of see how that can support your downstream use cases. So here's a very busy kind of overlay of all of the chunks on the original document. This is probably not what you want, but say that you have extracted just a limited number of fields and you want to you want to visualize the extracted fields only. So in this sample statement, we've extracted 3 values and they come from this text block and these 2 table cells. Or in this example, the answers came from this chunk, and this chunk. Or here, again, highlighting either a text block or a table cell. So this can be very powerful as you're building visualizations and doing kind of human in the loop to be able to say, this is the value we extracted and like, let us highlight it for you on the original. It allows for very quick kind of visual verification if necessary. So this one is in parse, classify, extract, visualize. And I think for the first time, actually covered all of the like intermediate content that I wanted to cover. So let me stop sharing there. We can take a few final questions and get you on with your day.
Yes, so we've got some great questions here. Could you please share the best practices for production pipeline?
That depends on what you're trying to build. Right. So in my sample projects just now, there's the RAG pipeline. So if you're preparing documents for RAG, right, and you're doing like a 50-page research paper, you're probably just going to gather all of your documents, do one big batch processing job, save the output. So it's not so much of a pipeline as it is a batch job, and then a way to, add 10 more papers next month and 10 more the month after that. If you're doing some sort of like real time, like say that you want to give people like they submit a handwritten form or they submit a photograph and like your website is supposed to return an answer to them instantly, right? Like in that case, you're going to need to parse and extract using the real-time API, integrate that with like your website to then return a response to the user. So there's really no one answer to like best way to productionalize. It really depends on what you're trying to build.
And our next and final question, how does it handle overlapping text and gridless tables with irregular random column widths?
It actually does really well on gridless tables, but you can't just have random things, right? So like as long as it has the layout and it's like you like poof, like removed the lines, it's actually going to handle that quite well. Um, Overlapping text. I'm trying to imagine an example of that. So it might be like a form and then somebody's handwritten something on top of that. That actually typically is detected pretty well. We don't often have like digital text on top of digital text, but if you have a signature or a hand note on top of other text, typically those can be separated. So you'll have to test that out for yourself.
Excellent. Thank you. And with that, we bring our session to a conclusion. Have a great rest of the week. And we look forward to seeing you on our new webinars. Have a great one. Bye.